Hi and welcome to the fourth class of number system. My name is Nishant and with me we have done 3 classes so far. We started in the first class with classification of numbers. Then we looked at rules of divisibility and finally summation of natural numbers. In the second class, we had touched upon the concept of HCM and LCM, where we understood the basic concepts, then looked at 3 LCM models and 2 HCF models. Then in the third class, we went deep into the most important concept of factors, and we looked at 7 different types of problems that can be formed using the concept of factors. Okay, and today we are going to touch upon another very important concept, which is the concept of cyclicity. So we'll use this concept to find out the last digit for a number and even the last 2 digits of a number. It can be product of numbers, it can be a number raised to a high power, anything. We'll try to understand what are the patterns and solve questions. Okay, again, a very important part. You will regularly have questions on this concept in CAT and other exams. So sit back, watch carefully, have your pen and paper in hand, take notes, and then later on revise what we have taught here. Okay, so let's start with the last digit cyclicity. And when I say cyclicity, basically what I mean here is, if you see here, units digit of x to the power n is equal to units digit of last digit of x to the power n. Basically what I mean is that if you have a number 147 raised to the power 45, if we are talking of what will be the last digit of this, then you only have to bother about the last digit of the number, which is 7 to the power 45. Whatever is before that, that is immaterial. So that is the first concept. Okay. So whatever is the number given, you only have to bother about the last digit of that number if the question is asking you the units digit of that. Okay, fine. Now if you see, basically the last digit or the units digit follow a particular pattern. And once we identify that pattern, then it becomes very easy to crack these questions. We have taken 7, for example. So if I look at the number 7 to the power 1, the last digit will be 7. 7 square, 7 into 7 is nothing but 7 square. So 7 raised to the power 2 will give you 9 as the last digit. We are only writing the last digit. 7 square is 49, so I'm writing 9. Okay, then 7 cube. Now 7 cube I can calculate in 2 ways because I'm calculating only the last digit. One thing is you calculate 7 cube, which is 49 into 7, which is 343, which is slightly more complicated because then 7 to the power 4, 7 to the power 5, you'll find it difficult. Rather, a easier method is that 7 square, you know that the last digit is 9. For the next power, just multiply this 9 by 7. You don't have to do whole of 49. Just multiply 9 by 7 and you will get 63 or 3. For the next power, multiply this 3 by 7, you will get 21 or 1. Okay, so you need not take the whole number. The last digit is good enough and multiply it by the next power to get the last digit. So 7 to the power 1 is 7. 7 into 7 is 49. So 9. 9 into 7 is 63. So 3. 3 into 7 is 21. So 1. And the moment you get 1, always remember, now it will start repeating after 1 if you have got 1. Otherwise also it may start repeating, but 1 is a short indicator that the pattern will start repeating now. So you see 7 to the power 5 again is 7, which I had got in 7 to the power 1 also. 7 to the power 6 is 9, which I had got in 7 square also. 7 to the power 7 is 3, which I had got in 7 cube also. And 7 to the power 8 is 1, which I had got in 7 to the power 4 also. So basically after every 4 powers, the last digit of 7 repeats. So this is what is cyclicity. Cyclicity is there is a pattern. And for the digit 7, we can say that it has a cyclicity of 4. The cyclicity is 4. Okay, so now if I have to calculate the last digit of 7 to the power 45, what will I do? Now the focus shifts to the power 45. Now 7, because it has a cyclicity of 4, this 45 you need to write in the form of 4x plus k. Okay, or basically what it means, you divide this 45 by 4. So when I divide this 45 by 4, I get a remainder of 1. Okay, so all powers of 4 are null and void. They become 0. You get 1, cyclicity of 1. That means the answer will be the same as 7 is raised to the power 1, which is 7. So the answer for this question is 7. Okay, or when we write in this format, basically your power, if it is 4k plus 1, if it is 4k plus 2, if it is 4k plus 3, and if it is 4k. These are the 4 possibilities. Now, the first part you can see 4k will get completely divided by 4. What you will be left is 1, 2, 3 or 0. If you get this, then the answer would be same as 7 raised to the power 1, which is 7. If it is 2, then the answer would be same as 7 raised to the power 2, which is 9. If it is this, then the answer would be same as 7 raised to the power 3, which is 3. And if it is this, then it is same as 7 raised to the power 4, which is 1. Okay, so this is the format. Good thing is that all digits follow this same pattern. Same pattern means they have a cyclicity, not cyclicity of 4, but they all have cyclicity. Let's try and understand that. Let's start with number 0. 0 obviously has a cyclicity of only 1, because 0, if it is in the last digit, any number, any power of 0 will end with 0. So 0 has a cyclicity of 1. Okay. So 0 has a cyclicity of 1. It will always give you 0. 1 also has a cyclicity of 1. Any number ending with 1 will always, any power will always end with 1. 5 also has a cyclicity of 1. And 6 also has a cyclicity of 1. Okay, so these, any number ending with 0, 1, 5 or 6, you raise them to any power, they will always end with 0, 1, 5 or 6. Very simple. Okay, then we have number 4. Number 4, if you check, 4 to the power 1 is 4. 4 square is 16. That means it ends with 6. 4 cube is 64, which is again 4. Okay, so any number ending with 4, you raise it to a power, it will end with 4 or 6. That means this has a cyclicity of 2. Okay, the cyclicity is 2. And similarly 9. 9 to the power 1 is 9. 9 square is 81. 9 cube, again you will end with something with 9, which is 729. So 9 also has cyclicity of 2. So 0, 1, 5, 6 have cyclicity of 1, 4 and 9 have cyclicity of 2, and the remaining digits, what remains? 2, 3, 7 and 8. All these have cyclicity of 4. Okay, 2 if you see, 2 to the power 1 is 2, 2 square is 4, 2 cube is 8, 2 to the power 4 is 16, 2 to the power 5 is 32, which is again 2. So you again get back to 2. Similarly 3 to the power 1 is 3, 3 square is 9, 3 cube is 27, 3 to the power 4 is 81, and I told you when you have 1, cyclicity will automatically start. 3 to the power 5 is 243, which is again 3. 7 to the power 1 is 7, 7 square is 49, 7 we looked at in the previous page, right? 7 cube is 343, which is 3. And again, you don't have to really bother about the power. 7 to the power 1 is 7, 7 square is 49, 7 cube is 9 into 7, which is 63. And 7 to the power 4 is 3 into 7, which is 21. So you again have 1. And 8 will give you 8. 8 into 8 is 64, so 4. 8 into 4 is 32, so 2. And then 8 into 2 is 16, so 6. And then 8 into 6 is 48, so again 8. So you can see that all these have cyclicity of 4. Okay, so all my digits have cyclicity of either 1 or 2 or 4. So what will you do in case cyclicity is 1? Cyclicity is 1, you don't really have to do anything. In case cyclicity is 2, you basically will have to divide the power by 2, and if the remainder is 1, then the answer is first one. That means the power should be of the type 2k plus 1, and in the second case the power should be of the type 2k. Here, if the cyclicity is 4, we saw in the previous example, if the power is 4k plus 1, then first case 4k plus 2, then second case 4k plus 3, then third case, and 4k, then fourth case. Okay, so I've summarized this in the next slide. See this. This is finally the summary. Cyclicity can be 1, 2, or 4. 0, 1, 5, 6 have cyclicity of 1. So the last digit will be same no matter what power you raise. Cyclicity of 2, 4 and 9. Last digit can be 4 or 6, or for 9 it can be 9 or 1. If it is 2x plus 1, then the answer would be first one. And if the power is 2x, then the answer would be second one. Similarly, cyclicity of 4 is 2, 4, 8, 6. Remember, it is 2, 4, 8, 6, not 2, 4, 6, 8. Okay. And similarly, we have for each one of them. If the power is 4x plus 1, then the answer would be the first one. Remember, answer is not 1. Answer is first one. That is when you raise that number to power 1. If the power is of the type 4x plus 2, then the answer would be same as raising the number to second power. If the number is of the type 4x plus 3, then it is same as raising the number to the third power. And if it is 4x, then it is same as raising the number to the fourth power. One more interesting thing that you should see is 2, 3, 7, 8. We also call them as complementary numbers, and they have certain special features which we do in squares and cubes also. But just if you see, 2 and 8 make it 10, and 3 and 7 also make it 10. So basically, just to remember, 2, 3 and their complements have a cyclicity of 4. That is what you can remember. Okay, very simple concept, but very, very useful when you have to find the last digit. Let's do a few questions to understand this. And of course, questions can be elementary, but fairly complicated questions can also be made, though the concept is very simple. Let's look at this, for example. We start with a simple question. I hope you find this a simple question. Okay, first is 248. I told you at the start, you don't have to bother about 248. You only have to bother about 8. Okay, you only have to bother about the last digit, first part. Then 8. 8, you should remember, has a cyclicity of 4. So 4, 6, 6, 7, you'll divide it by 4. Okay. And my objective is only to get the remainder. So for divisibility by 4, you know that you have to check the last two digits. So last two digits, 67, if you check, you'll see that 64 will get divided and you will get a remainder of 3. That means 4, 6, 6, 7 is of the type 4k plus 3, right? So the answer should be same that you will get by raising 8 to the power of 3. Okay, so 8 to the power 1 is 8. 8 square is 64 or 4. Just write 4, okay, don't complicate it. And 8 cube will be 4 into 8, 32 or 2. So the answer is going to be 2. Right? You may not remember what will you get when, just check the powers. 8 to the power 1 is 8. 8 square is 64. So 4. 8 cube is 8 into 4, 32. So 2. So the answer would be 2 in such a case. Okay, very simple. That's how these questions will be done. Don't bother about how large is the base. The base is the number which is raised to the power, because we are only concerned with the last digit. Don't bother how large is the power, because we have to divide it by 4 and only focus on the remainder. So as large is the base, as large is the power, does not really matter. The power will be divided by 1, 2 or 4, and you only have to focus on the remainder, which at max will be 3, will be anywhere between 0 to 3. So very, very simple. This is how this can be done. Okay, let's look at next question. Okay, so this looks a bit complicated. What is the unit digit of 1 to the power 781, 2 to the power 781, 3, 4, 5, 6? We have up to 9. Okay, so we'll have to check the cyclicity of all of them. Fair enough. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, you know that gives you 1 only. 5 gives you 5 only. 6 gives you 6 only. So for these, though, it is easy. Then we have 4 and 9. 4 has a cyclicity of 2. Okay, and the power is same for all of them, 781. 781 obviously divided by 2 will give you a remainder of 1. So the answer will be same as 4 to the power 1, which will be 4. 9, it will be 9 to the power 1, which will be 9. Similarly, 2, 3, 7, 8 now have cyclicity of 4. 781 when divided by 4 also gives you remainder of 1. So it will be same as 2 raised to the power 1, which is 2. 3 raised to the power 1, which is 3, 7 raised to the power 1, which is 7, 8 raised to the power 1, which is 8. So if you see, in effect, you get the same digits 1, 2, 3, 4, 5, 6, 7, 8, 9. Here also you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are the last digits. If you add all these last digits, 1 to 9, summation of 9 is 9 into 10 by 2, which is 45. So the last date is going to be 5 and your answer will be first choice, right? As simple as that. So nothing really complicated, though it looked like a long question, but you can see it can be done so easily. Okay, let's move to the next question. The rightmost non-zero digit of the number is what? Now here if you see, we have 30 to the power 2720. Now this 0 that is there will give you a lot of zeros in the end. Okay, and after 0, what will be the digit, or just before 0, what will be the digit? That will be determined by 3. So this 0 you can ignore. This question basically same as 3 to the power 2720 if I have to find the last non-zero number. Okay, and that is what the question is asking. So basically 0, because 0 will give you a lot of zeros, that I'm not concerned with. So 3 has a cyclicity of 4. So 2720 divided by 4 gives you remainder of 0. So remainder of 0, that means the last date will be same as 3 to the power 1, which, no, sorry, remainder is 0. So last date will be same as 3 to the power 4, which is 3 to the power 1 is 3, 3 square is 9, 3 cube is 9 into 3, 27, and 3 to the power 4 is 7 into 3, 21. So your answer is going to be 1. Okay, so when remainder is 1, the answer is first one. When remainder is 2, when remainder is 3, and when remainder is 0, remember your answer is the fourth one. Okay, so answer is going to be 1 in this case. So this again is a simple question. Let's look at the next one. Find the digit at the units place of 1 to the power 1 factorial, 2 to the power 2 factorial, 3 to the power 3 factorial, 4 to the power 4 factorial, up to 80 to the power 80 factorial. See, the trick of all these questions would be basically to find a pattern, because you can't solve up to 80. Of course, there has to be a pattern after which it will start repeating. Okay, so where will that repetition happen? That is what we have to crack. Okay, so let's start with 1. Now 1 to the power 1 factorial basically means 1 to the power 1. So my last date is 1. 2 to the power 2 factorial means 2 to the power 2 or 2 square. So my last date is 4. 3 to the power 3 factorial. Now 3 factorial basically means 6, right? So 3 to the power 6, and 3 has a cyclicity of 4. So 3 to the power 6 is same as 3 to the power 2. So last date will be 9. Then 4 to the power 4 factorial. Now 4 factorial will be 24. 24 divided by 4, remember, has a cyclicity of 2. So 4 divided by 24 divided by 2 will give you remainder of 0. So this will be 6. 4 has cyclicity of 4 and 6, right? Then 5 to the power 5 factorial does not matter. 5 will always give you 5. 6 to the power 6 factorial does not matter. 6 will give you always 6. 7 to the power 7 factorial. Okay. Now 7 factorial will be how much? 6 factorial, 5 factorial is 120. 6 factorial is 720. Okay. So 7 factorial will be 720 into 7, which will be 5040. Okay, and this I will divide by 4. So you can see that this will get fully divided. So remainder will be 0. So it will be the fourth power. So 7, then 7 into 7 is 49. So 9, 9 into 7 is 63. So 3 into 7 is 21. So 1. So this will give you 1. Similarly, 8 to the power 8 factorial. Now, obviously, now you can notice that all these numbers are multiples of 4. 7 factorial itself was a multiple of 4. So 8 factorial also will be a multiple of 4. So the answer would always be the fourth one. So in case of 8, it is 8, 8 into 8, 64, 8 into 4, 32, 8 into 2, 16. So this is going to be 6. Okay, 9, 9 again, 9 factorial will be a multiple of 4. So obviously it's a multiple of 2 also. So it will be second one, 9. 9 square is 81. So 1, and 10 to the power 10 factorial obviously will end with 0. Okay, so this is what we get. No particular pattern so far, right? You can see that all of them are giving you different digits. Let's look at 11. 11 to the power 11 factorial. Again 1, so it has to be 1. 12. 12 again. When I write 12, you only have to bother about 2, right? So 2. 2 to the power something which is a multiple of 4. So 2, 4, 8, 6. So 2 is giving different answer here. Then 13 to the power 13 factorial. Again 3, fourth power of 3. So 3, then 3 square is 9. 9 into 3, 27, and 7 is 1. 1. So this again is giving a different answer. Then 14 to the power 14 factorial is 4. So 4 will give you same, 4 and 6. 15 to the power 15 factorial. This will always give you 5. 16 to the power 16 factorial will always give you 6. 17 to the power 17 factorial. Now 17 factorial again is a multiple of 4. So fourth power, same as this one. So it will be 1. 18 to the power 18 factorial. So this again should give you same because 8. So 6. Then 19 to the power 19 factorial. Same, you will get 1. 20 to the power 20 factorial. You will again get a 0. Now you would see a pattern because when I take 21 factorial, now 21 to the power 21 factorial, it will be same 1. 22 to the power 22 factorial is same as this because 2 to the power 12 factorial and 2 to the power 22 factorial are same. Both of them are multiple of 4. So you'll get same 6, you'll get same 1, you'll get same 6. So this will repeat. First 10 will not repeat, but this will repeat. 11 to 20, same you will get from 21 to 30, same you will get from 31 to 40, same you will get till 71 to 80. Okay, 1 to 10 is different. So let's write down the last digits for 1 to 10. Let's add them. 1 plus 4 is 5, 5 plus 9 is 14, 14 plus 6 is 20, 25, 31, 32, 32 plus 6, 38, plus 1, 39. So last date is 9. Okay, so for 1 to 10, last date is 9. For 11 to 20, my last date is how much? 1 plus 6, 7, 7 plus 1, 8, 8 plus 6, 14, 14 plus 5, 19, 19 plus 6, 25, 25 plus 1, 26, 26 plus 6, 32, 32 plus 1, 33. So my last date is 3. And same pattern will follow 7 times. 11 to 20 and up to 71 to 80. So I can say this will be 7 times. So 3 into 7, 21. So this will give me 1. Okay, as the last date. So this is giving me 9 as the last digit. This is giving me 1 as the last digit. When I add them, I get 0 as the last digit. Hence my answer is going to be the first choice. Hope we are clear with this. I told you that you have to find a pattern. From 1 to 10, there was no pattern, but 11 to 20, that pattern repeats. So 1 to 10, the last date is 9. 11 to 20, the last digit is 3. 21 to 30 also, the sum will be 3. 31 to 40 also, it will be 3. 41 to 50 also, it will be 3. So basically, all those 10 digits will be 3. So there will be 7 such groups. So 7 groups ending with 3 each. That means their total will end with 21, which means last date will be 1. Okay, so 1 to 10, the last date is 9, and 11 to 80, the last date is 1. So if I look at 1 to 80, the last date will be 9 plus 1, which will be 0. Hence, the answer will be 0 for this question. Okay, so we have taken from simple to fairly complex problems, all this where we are looking at the last digit or the digit at the units place.